Okay, everybody got that? So, just to summarize, I'm using this red vector to go from the origin to here. And the red vector is going to be, of course, the same 0, 9, 30 vector here, plus Tm, right? And Tn is 9Ti, just multiply each one of these by T, right? Get 9Ti plus 1.1 Tj plus 3.2 Tk. Adding that to the 0i plus 9j plus 30k vector, it goes from here to here. You got the sum of this and this, which is this red vector. There it is. Leading us to the point, the x-coordinate is going to be 0.9t, y-coordinate is going to be 9 minus 1.1t, z-coordinate 30 plus 3.2t. So, that's it. We can write this as x equals 0.9t, 9 minus 1.1t, 30 plus 3.2t. Okay? These are called parametric equations. T is the parameter. We have an equation for x, an equation for y, an equation for z. And any point on the line is going to be in this form for some value of t. And the further you go in the positive direction, the bigger t is going to be. The further you go in the negative direction, the bigger the negative quantity, right? For t. So as t goes from negative infinity to infinity, you go from one end of the line to the other. Oh, the line doesn't have ends. You get the whole line, which approaches infinity in both directions for that reason. Okay, so these are your parametric equations. For a straight line. Now there are advantages to always normalizing this normal vector, making it a unit vector, okay? Because in that case, the three coefficients of t will have squares that add up to 1, right? The coefficients of t are just these components. If this is a normal vector, a unit normal vector, then that's good, because if you've got another line which also used a unit normal vector, okay, line out here somewhere that used a unit normal vector, you can tell at a glance if those two lines are parallel, right? If you have a normalized unit vector, the only way another normalized unit vector could be parallel to it would be to either have the same components or the negatives of the same components, right? Okay, so it's useful to use unit normal vectors. Okay, there's another question we might want to ask. Can we get the equation of the plane perpendicular to this normal vector through the point? Now that plane would pass through these two edges, right? So that plane would contain this point, and this point. Look at your objects there, okay? Sitting over there, grab them if you want to. It kind of helps to actually look at the physical object. And pick any two sides for these two sides, orient the thing any way you want to. Okay? Yeah, better get the right one or get confused. Okay. Again, pick any two edges, upper edges you want here, and visualize the plane through those edges. Okay? If you put a piece of glass down over that plane, or over those, this point, and this point, right? You might not be able to do that because this point may be too high. Okay? But you could get a plane. So now we want to talk about the equation of a plane. Actually, in many ways simpler than the equation of the line because it's not a parametric equation.